Okay, let's get this started. Okay, so let's review some more on some more pre-calc review. Okay, so we started talking about, okay, so pre-calc review, I guess part 2. Okay, we started talking about functions. So really the most important function that we're going to need in this class are lines. Really, lines are the most important ones that we're going to need. So a line is really determined by 2 points. Let's say 1, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Let's say we have 2 points and 4, 5. Okay. So for a line, what we care about very much is the slope, right? The slope tells us how steep is the line, how shallow is the line, is it horizontal, is it vertical? How do we get that slope? Well, what you need is you need to measure like the 2 points, the run. There's the run, horizontal distance between the 2 points, and then there's the rise. Okay. So that's how you get the slope. So the slope of a non-vertical line through x naught, y naught, and x1, y1, or actually x1, y1, and let's do x2, y2. That's the more standard notation. x1, y1, x2, y2 is, we use the letter m for slope. It's the rise divided by the run. When you take the rise here divided by the run, that tells you the slope. So the rise, when I go from 1, 3 to 4, 5, what's the rise? How much did I rise? Right. What is it? 2. Good. And what's the run from 1, 3 to 4, 5? How much did it run horizontal? 3. Good. So when you divide those numbers, that gives you the slope. So rise over run. The formula would be y2 minus y1 divided by x2 minus x1. It doesn't matter which point you pick x1, y1, you'll get the same answer in the end. It doesn't actually matter. So you could pick x1, y1 to be 1, 3. You could pick x1, y1 to be 4, 5. It doesn't matter. Just as long as you stay consistent. So in this case, y2 minus y1. So let's say this is x2, y2. So it'll be 5 minus 3 is the rise. Okay. And the run, what should I put in the denominator? Which 2 numbers will be the run? Okay, 4 minus 1. So I get 2/3. Okay. And if you picked, you switch the points, like 4, 5 was your first point, 1, 3 was your second point, believe it or not, you'll get the same answer. Okay. Either way, you'll get the same slope. Okay, so it's up to you how you want to pick them. Here's a little example. Find slope of line through -1, 5 and 3, 13. Right? Take a moment. Take a moment to compute the slope between those 2 points. Was that 2? Okay. Okay, we're going to work through it. We'll work through it together. Remind me your name? Alan? What's your last name? Last name is Alan? Oh, Shariful? Okay. Let's see. So do we have, is Mia Dual here? Mia Dual? Yeah, so what do you, how would, Mia Dual, how would you compute the slope? What should I put in the numerator?
Points minus 5, 1, so I did 13 minus 5.
Good, 13 minus 5. So you pick this as your second point, this is your first, good. And what'd you do for the denominator?
3 minus -1.
3 minus -1, good. So we get 8 divided by 4, which is 2. Good. A question on this? Okay. What about -1, 5 and 3, 5? Let's see, is that Becca?
Yeah.
Becca, yeah? Yes, what's the slope between those two?
0, 0.
Which is 0, right? It's m equals 5 minus 5.
Over 3 minus -1.
Good, 3 minus -1 is 0. And what does that look like? What does a slope 0 line look like?
Horizontal line at 5.
Horizontal line at 5. What was your name?
Raphael.
Raphael? Okay, like Raphael said, slope 0 means that at 5, I have a horizontal line. That's what a slope 0 is. You guys should measure everything from 0. So a slope 0 lines like this, and then positive slope will be like this. You know, big numbers like 100 will be really steep. Small numbers like a half will be very shallow. Okay, so bigger numbers are steeper slopes. So like 2 would be a line like this. Okay. Slope of 2. And then if you want negative numbers, so if m was like -1/2, well, the 1/2 means it's pretty shallow, but then the negative also means it's going the other way. It's a negative slope. So this is positive, and the hand this way would be like negative. That's something like that, a little sketch. You want to have a pretty decent idea of what these slopes look like, okay, so that you could draw them. Okay, so equation of a line. You want to write the whole equation. Through x naught, y naught, and slope m. Okay. So all you need to write down an equation of a line is you just need the slope and a point. Once you have a slope and a point, you're just going to use this formula over and over again. So y minus y0 is equal to m times x minus x0. Right, this is the point slope form. Okay, you could get any equation of a line just with that formula. Right, so you just need to make sure you get the slope and you get a point. So right line, I guess right equation of line through -1, 5 and 3, 13. Right, write the equation of a line through those 2 points. Okay, so every single question like this could be answered is you need a slope and you need a point. Well, you have 2 points. Which one do you pick? Any one. You'll get the same answer. Any one you pick. Which one should we pick for the point? What do you guys want to use?
-1, 5.
Which one's more appealing? -1, 5? Okay. And what's the slope? 2? Right, it's the one that we computed before. What's your name?
No, Sultan. No, Sultan. I'm the new.
You recently joined?
No, it's my first
Let's
class.
see. Is it Nur Sultan?
Yeah.
How do you pronounce it? Is it Nur Sultan?
Yeah. Not Sultan.
Nur Sultan? Okay, so we already got that the slope was 2. So all you have to do, pick whatever point you like, as long as you have the slope. So y minus 5 is equal to 2, which is the slope. What should I write? X minus -1, exactly. -1. Okay, let's see, what's your name? Lista? That's it. That's a good answer. You don't have to simplify in this class. You guys are used to simplifying in algebra. You don't have to do it. Yeah, we actually did. We already did it. This was the same points we had before. So it's 13 minus 5. 3 minus -1. Yeah, you do have to calculate the slope. That's right. You do have to get the slope.
Yes.
I just wrote down 2 because we just did it. We did it before, so we calculated the slope. So if the slope's not given, then you guys have to calculate. Okay.
Like y minus y1 by 6 minus 6. y1 minus y2 by.
Yeah, but you'll still at some point need to, yeah, like either formula that you use, it is calculating the slope somewhere. So the important thing is the coefficient in front of the x is the slope. So WebAssign won't accept it like this. You'll have to do like y equals 5 plus, let's say, 2 times x plus 1. So what's nice for us is that the number in front of the x is the slope. So you see a 2x, the slope is 2. All right, so another nice advantage of this formula is you kind of just grab the slope. Okay, so let's, now that we have a formula, what does it mean for two lines to be parallel? We have y is equal to m1x plus, let's say, b1, and y equals m2x plus b2. Okay, first of all, what's the slope of this line right here? Y equals m1. M1, right? The number in front of the x is the slope. What's the slope of this line? M2, right? So for lines to be parallel, order for them parallel means they'll never meet. Like they'll go on forever and ever. They'll never cross each other. Okay. So if you just do a hand motion, know what it means. Notice that the slope is parallel. Right? They don't go through the same points. They don't have to go through the same points. But the slope is the same. Right. So parallel, if M1 equals M2. Slopes are the same, we'll make them parallel. Perpendicular. Right, what does it mean when lines are perpendicular? Well, that means you have a line and another line where they do cross, but at a right angle. So this little square means a right angle. They cross at a right angle, that means they're perpendicular. Okay. So if you guys remember, to be perpendicular is you need M1 to be the negative reciprocal of M2. So you have to take the reciprocal of the slope, but then multiply it by a negative sign. But as soon as you do that, you'll get perpendicular. So same slope will make it parallel. Negative reciprocal will make it perpendicular. So what would be a typical question? So an example is part A, line through 6, -3, and parallel to y equals 11x plus 2. Okay, so you guys have to find a line that goes through this point. It's parallel to this other line. Okay, now remember, every single question to be answered is you need a slope. You need to figure out what the slope is, and you need to figure out the point, right? You have to figure out a point and a slope. Okay. Take a couple minutes, see if you could figure out the equation of a line. Figure out what the slope needs to be. Figure out what the point needs to be. Just give everyone a moment. Okay, good. Okay, someone else want to try it? Let's see, Layla?
We want them to be parallel, we take the slope from the equation that was given, which is 11.
Good. We read off the slope.
What I did was I plugged in the points into into y equals mx plus b, which would be -3 equals 11 times 6 plus b, and then solved for b, and then just made the new equation.
Okay, so you want to use this formula, 11x plus b. Okay, you could use that. It's a little bit more work, but then you have to find b if you do it like this. So you plugged in -3 and 6. Because you have to find b, right? 11 times 6 plus b, then b is equal to -3 minus 11 times 6. Is that what you did? Okay, so you could do that. So then it's y equals 11x, then -3 minus 66. That works. But if you use this formula right here, there's no work to be done. You could all do it all at once. So then if I use this formula, which is the point slope, y minus y0 is equal to y minus -3, y plus 3 is equal to the slope, which is 11 times x minus 6. You could write it this way. So it'll save you time. Right? You could solve for b, but then who wants to solve more stuff? You could just write down the answer and then don't have to solve anything. But if you like mx plus b, you're used to, your pre-calc teacher always taught you mx plus b, you can do mx plus b. So that's the point slope. Questions on this? What if I want a perpendicular line? Right, how about for part B, let's do perpendicular. So same question. For B, but let's do perpendicular. So this symbol means perpendicular. Perpendicular to y equals 11x plus 2 through the point, same point, 6, -3. So again, you guys have to figure out the slope. You need a slope and a point. Yeah, Jackie?
The answer.
What is it? Yeah, you can say the answer, sure.
So wouldn't it just be y plus 3 equals -1/11?
-1/11. How'd you do -1/11?
So negative reciprocal.
Right, negative reciprocal, right? Times
X minus 6.
x minus 6. Right, one and done. That's it. Good. Okay. Questions on, does this make sense, guys? Yeah? Right. Do you see the difference between the two? Right, the same line, the only difference is the slope. Yeah, question?
Can you explain how you get the perpendicular one?
Perpendicular, yeah, so perpendicular. If you want a line to be perpendicular, just take the slope, take the reciprocal, and then multiply by a negative. Yeah, so that's the formula. So just, you could always get a perpendicular line by doing negative reciprocal of the slope.
Okay.
So I just use this formula right here. For perpendicular, is I need this slope to be the negative reciprocal, and you can get perpendicular. Okay. Just a little terminology, the y-intercept of function y equals f of x. Question?
Preference whether submitting the y-intercept form or just the mx plus b form?
Oh, the point slope? Yeah, so normally it's just nicer with point slope just because with a point slope form, you see the point right away. and you see the slope, so it's like really easy to grade. Like I wouldn't take off, but y equals mx plus b means I'll have to calculate to make sure you got the right b. So with the point slope, the point is right there, the slope is right there. It's like really easy to read. Okay. But up to you. You could use mx plus b.
PP.
Yeah, but most math textbooks will use the point slope. Just because it's less work to use. Y-intercept of a function is y value when x equals 0. So when you talk about a function, okay, so the y-intercept is when it goes through the y-axis. So you're setting x to 0. You could also talk about the x-intercept. That's where you set y to 0. Okay. So x-intercept is x values where function crosses x-axis. Right, and the x-axis is you're setting y to 0. So if you see the web assign asking for x or y intercept, it's kind of like a graphical thing that you can visualize. So here is y-intercept. And x-intercept, you could have multiple here, x-intercept. That's what they're asking. So y-intercept kind of set the other variable to 0. X-intercept, you'll set the other variable, which is y equal to 0. So as an example, find slope and y-intercept of line 5x minus 3y plus 9 equals 0. Okay. Now you just want to be careful. I told you guys the slope is the number in front of the x, but that's only if y is isolated, only if y is by itself. Okay, so if you want to get the slope, isolate y. So you have to solve for y by itself. And then that'll help you get the slope of the line. Okay. So find the slope of the line and find the y-intercept. Is there a question, Nur Sultan?
Answer.
Answer?
Yeah.
Okay, yeah. How did you do it? What did you do for this?
Is 5, 1, 2, 3.
Mhm.
And the intercept is 3.
And how did you do it? When I solve for y, what do I get?
Move it 3 equal to the right side,
Other side, good. So 5x,
and I divided 3 to the other side. Divide
3y, and then you divide both sides by 3. So y is equal to 5/3 x
plus 3.
plus 3.
And the slope is 5 divided 3.
Right, and that's the slope. Good. Good. And Shariful, that's what you wanted to give an answer also?
Yeah.
Okay. Okay, good. Yeah, so you guys have to solve, do a little algebra, get the y by itself, read off the slope. M equals 5/3. Okay. Y-intercept means I'm setting the other variable to 0, which means I'm setting what to 0? The x to 0. So then y is equal to 5/3 and 0 plus 3. Yeah, I'm setting the x to 0. That's the y-intercept. Very good. Questions on this? Oh, you mean like, what if you said the slope was 5? Or,
If there was a question, and you have 10 out of 6, would
okay.
you accept that? Or would you want to-
Oh, you mean just simplifying a fraction? No, you could put 10 out of 6. Yeah. Yeah, you don't have to simplify anything. Good. So I put 5/3, but if you ended up with 10 out of 6, it would be the same thing. Don't worry about simplifying. The important thing about these is just read out the slope. You'll need to isolate the y. Okay. Fine, let's try another one. How about a line through 6, 7 and perpendicular? This symbol means perpendicular to 4x plus 11y equals 19. Okay. So remember, every line you need a point and a slope. So figure out what the point is. And then now you need to get a slope. So you have to get a slope. And then use what you know about perpendicular to get it. Oh, you already did the negative reciprocal. Okay, yeah. Yeah. I'm just gonna give people a couple more minutes. Just try it. Okay, so we get a couple more people and see Ronaldo. Is Ronaldo here? Ronaldo. Ronaldo here? Ronaldo? Yeah, so what's the slope of this line? How do you get it?
Slope would be 4/11.
So almost, so we need to first subtract the negative 11y, or subtract the negative 4x, either one. So notice that when we subtract, it's negative 4x plus 19. Be a little bit careful. We put a negative. And then what should we do with the 11?
Divide both sides by 11.
Right, divide both sides by 11, so negative 4/11 x plus 19 over 11. Now let's try. So what's the slope of this line?
Negative 4/11.
But negative 4/11. So now to be perpendicular, I need the negative reciprocal. So what would that be?
Would be 11/4.
11 over 4. Good. It's like Ronaldo's saying. So the slope is going to be negative reciprocal 11 over 4. And the point is 6, 7. Okay, so we have a point and we have a slope. We can just write it down. So y minus 7 is equal to 11 over 4. X minus 6. And that's it. The only difference is in WebAssign, you'll have to move the 7 to the other side. You don't have to simplify it, but in terms of entry, it'll be like y equals something. So you have to write it as y equals something. It might force you. Okay. On an exam, you just do this and forget doing extra work simplifying it. What's the point? Just write it down and it's a perfect answer. Full credit. Okay, any questions on this? Okay, thumbs up if this is making sense. Okay. Thumbs down if you're getting a little. Is it iffy? Is it still iffy for people? Is a lot of this familiar, at least? Okay. Just make sure we get this. How about this horizontal line? A line through 8, 1. Okay, so they gave you a point. They did give you a point. But you have to figure out what the slope would be. So just think about horizontal. What slope is that? 0, right? 0 slope. So m equals 0. So then y minus 1 is equal to 0 times x minus 8. So y equals 1, right? That's how a horizontal line will be. It'll be y equals something. So horizontal lines are y equals a number. You could have just read it off by saying like, oh, it's horizontal through 8, 1. The 8 doesn't matter, it's horizontal, so it's just y equals 1. So you could have read it off, but this is, I guess, the more just formal, more formal way to do it. Okay. How about vertical line? What is that? Vertical line through 8, 1. See, Selena?
X is equal to 8.
X equals 8. Right. How did you get that? Because what slope do we have?
There's no slope.
Yeah, we don't really have a defined slope. If you try to use the formula, the denominator would be 0. Right? In your slope formula, vertical lines have a 0 denominator. So how'd you get x equals 8? Yeah.
Well, if it's vertical, it stays at 1 point for x and then goes up through all of the y's.
Right, exactly. Good. Like Selena's saying, we just use intuition basically. It's vertical, so the x value just has to stay at 8 the whole time. So 8, like that. X equals 8. Okay, so you'll have WebAssign questions online, just like this, right? So it'll just give you a bunch of questions. I think a lot of them are just you have 2 points and get the lines. You use the slope formula. And then some of them are like parallel and perpendicular. So all these variations. Okay, but this is the most important function we need for this class, believe it or not. Calculus is all about lines. So lines are the main thing that we're going to need to do all the later problems. That's why we spend so much time. That is the key. Okay, one more example. Line with x-intercept 10 and y-intercept -7. Okay, so for this one, it might help to draw it a little bit. Like draw what it would mean for a line to have x-intercept 10 and y-intercept -7. And if you draw it correctly, you'll be able to read off 2 points of your line. You could read off 2 points of your line and then get the equation. But yeah, draw it first. So is there a question or answer? Answer. What's your name?
Matthew.
Matthew. Let's see. Yeah, 2 Matthews. Matthew I. Yeah. What 2 points did you get?
So for the y-intercept, it would be 0, -7, and for the x, it would be 10, 0.
Okay, good. Yeah, so I'll just give everyone a minute to try that. Yeah, so try to draw it, and like what Matthew's saying is that the intercepts already give you a couple points on your line, right? Intercepts, you know, they disguise a couple of the points. Right, so it has to be a line like that. Like Matthew's saying, so that's why when you draw it, oh, 10 comma 0 is a point. And then 0 comma -7 is a point, so I have 2 points. And if I have 2 points, I can get a slope. -7 minus 0 is the rise. 0 minus 10 is the run. So I get 7/10. Positive slope. Okay. In terms of writing down the equation, I could pick any point I like. Let's say this one. So y minus 0 is equal to 7/10 times x minus 10. Sure enough, if you picked 0 comma -7 as your point, you get the same equation. Might look a little different, but after some algebra, it'll be the same. Okay, any questions on this? The other side of the room, in the back. Hmm?
-7, x -7.
Let's see, x. Oh, it depends which point you use. Yeah, so I picked 10 comma 0. So I picked 10 comma 0 for my point. So then the x coordinate is 10 and the y coordinate is 0. 10 comma 0 here. If I pick 0 comma -7, then it would be something what you're saying. So it's y minus -7 is equal to 7/10 x minus 0, so just x. Was that your question or?
No. -7 minus 0 is still -7.
Oh, you mean right here?
That's probably what she was talking about, but you simplify anyway, because it's 0 minus 10, negative over negative.
Oh, that's what you mean. Yeah, Layla. So I simplified it. So you're right. It's -7, but divided by -10. So I cancel the 2 negatives. So then I turn it into 7/10. So that's it. Yeah. Yeah. So if you put -7 over -10, it would have been the same thing.
-7, so in the end, it should come out to y equals 7 over 10x minus 7.
Well, the slope is 7/10 though. Yeah, you have to be careful.
It cancels out when you.
Yeah. Oh, you mean like a little bit of algebra? Yeah, yeah. So yeah, if you guys did the y equals mx plus b, you would have had to do a little algebra. And you can't get a different answer. So 7/10 times 10. You mean that -7? Yeah. Yeah, but it'll come out to be the same after a little bit of algebra. Okay. So let's do another thing that we're gonna need. You've seen in pre-calc is piecewise functions. Yeah, so piecewise. Right. So a piecewise function is just like it sounds. It's you have multiple functions, there are different ones. You kind of glue them together. You glue different functions together, like I might want a sine wave, and then I want the sine wave to stop, and then I want it to become linear with a line. And then I might want the line to stop and then become a quadratic. We could glue multiple functions into one, right? How do we glue, right? Who has any glue? We don't have the glue, so we have to use math to glue them, right? But that's the idea. We can glue as many functions as we want together, right? Mathematically, how do we glue? Okay, we glue by specifying the function and the domain of that particular function. That's all we really need. Even if you have 3 functions, you'll just specify 3 different domains. We'll glue, let's glue. Okay, f of x equals y is equal to, first I want it to be this line, negative x minus 2. And I want it to be that for x's in between negative 2 and negative 1. Okay, so I want to start off with this line, but only for x's in between negative 2 and negative 1. First of all, what's the slope of this line? Minus x minus 2. What's the slope? Negative 1, right? So negative 1 in front. Okay. So we could already recognize it as a line. X plus 1, then I want to glue to it x plus 1. Let's glue. Okay, now how do we glue? We glue by taking the endpoint, which is negative 1. So we start at negative 1. So this function ended at negative 1. This function is going to start at negative 1. And we're going to do less than x less than or equal to 1. So between negative 1 and 1, it's going to be this line, right? So we have 2 different functions, but we glue them together at negative 1. That's the idea. We can glue 2 lines at negative 1. And we could even glue a third one. Why not? How about negative x plus 2? Okay, how do we glue? Is we have to take this endpoint here, which is ended this function, and we'll start at this function. Less than or equal to 2. Right, now I say glue, but glue doesn't necessarily mean we have to connect the functions. We could connect the functions. Glue just means on your paper, kind of. So one function could be here, and I can glue the other functions, the second function here, as long as they're not on top of each other, right? So I glue them on the paper, but as long as they don't overlap when I look vertically. Because if they overlap, that's not a function. Remember, vertical line test, I can only have a function if the vertical line only passes through 1. Okay, so how did these get glued together? Now we can graph it. You guys have to graph it. Okay, so how do you start it? You could just start with the first function. You could just start with the first number you see, negative 2. So you're going to plug in negative 2. Okay. And when you plug in x equal -2, notice -2 is part of the first function. -2 is not part of the second or the third. So -2 is part of the first function. If we plug in x equals -2, what's going to be our output?
It's 0.
0. What's your name?
Cameron.
Cameron? Like Cameron is saying, if we plug in -2, the output is 0. And because it's an endpoint, we have to decide if it's an open circle or a closed circle. So the way you decide is with an equal sign. So equal sign means it's part of the function. So that means this point is really part of the function because of the equal sign. So I'm putting a closed circle. And then the next point I could plug in, I guess I could just go straight to -1. If I plug in -1 for x, what do I get? -1. -1. Right here. Closed or open? Closed. Right, because I did see the equal sign there. And it is a line, so I don't have to do so much in between because it is a line. I just put it like this. Now I'm going to start gluing the next function, but it can't overlap here. So I just start with the next endpoint. So -1, and I'll put it here. If I plug in -1, what do I get? -1 plus 1 is 0. The output is 0. Okay. But is it open or a closed circle? It's open. See, there's no equal sign. That means it's a fake point. It's a fake out. It's a fake out to help you draw. It's not actually there, right? See, -1 for this function should go into the first one, not the second one, right? Because -1 is here, which is the first function. So here I have to put an open circle like that. And how about the next point I could plug in? I go from -1 to 1. Let's make it easy. So let's plug in 0. If I plug in 0, I get 1. Open or closed circle? It is closed. Yeah, it's closed because it's lying in between. So if it's lying in between, it is part of this function. Okay. -1 was a fake out for that function, but not this one. And if I plug in 1, what do I get? 2. I get this point, open or closed? Closed, because it's an equal, and it's a line, so I could just connect the dots. It is a line. Now you guys try the third piece. Try to get the third piece. Similar to what we did, right? You start with the first number. You keep going down to the last number. Try to connect the dots. Right. Try to plug in 1, try to plug in 2. Oh, yeah, let's see. Okay.
This would be considered a function because it passes the vertical line test.
That's right, that's right. As long as I could glue whatever I want together, as long as I pass the vertical line test. And the way you know it'll pass the vertical line test is you could just look here. -2 to -1 does not overlap with -1 to 1, does not overlap to 1 to 2. So I never overlap. Okay, good. Okay, if I plug in 1, what do I get? Layla? Get 1. 1 comma 1, open or closed circle? Open. If I plug in 2, I get 0 open or closed? Closed. And that's it. Right, this is all one function. Right, it's all one function, which is gluing 3 pieces together, right? And I could glue things any way I want, and it's still a function, as long as my domains for each part don't overlap. Okay, they never overlap. I passed the vertical line test. Okay. Who can see what's the domain? Now, remember, the domain are all the x values that are getting plugged into this function. You can see which Matthew, what is it?
-2, 2.
-2 to 2, good. And Sheriff, what you were saying something? Would you put a closed bracket or an open? Closed. Yeah, how do we know it's closed? Because -2 is included, and then 2 is included. Okay. So two ways you can get the domain, either just look at the graph, see all the x values that get plugged in for the function, or you could actually just read it from here. From here, you could see all the x values that are getting plugged in. So all the ones from -2 to 2. The range. Now remember, the range are all the y values. So you could stare at the graph and see what are all the y values getting hit. It's -1, comma 2, bracket, good. Okay, what was your name? Let's see. Rachel. Right, like Rachel's saying, again, you could use the eyeball test, just see all the y values, where the y values start. They start at -1 and they end at 2. The only thing you might want to check is like, uh-oh, I see an open circle, so does this y value get hit? And you have to check that, oh, it does. And I see another open circle, it's like, oh, does this y value really get hit? But yeah, it does, so one does get hit. Okay, so really all the y values from -1 to 2 are getting hit. Okay. What is f of -1? Don't look at the function, but stare at the graph. Can you tell me what's f of -1 just by staring at the graph, not the function? -1. Okay, your name?
Sandra.
And Sandra. Okay. Yeah, so the way you tell is you look at x equal -1. Now the output, it has to be the open circle or the closed. You have to go with the closed. Right, because the open circle is not really there. Right, that means open circle means that point is not part of the function. It's not part of the graph. That's why Sandra is saying the output is -1 and it's not 0. Let's do another example. So for you guys to try this example. F of x is equal to 2x for x less than 0, x squared for x between 0 and 4, and -x for x greater than or equal to 4. Okay, so x less than 0 means like all the negative numbers, -1, -2, -3. So there might be infinitely many points to plug in, but you should be able to detect a pattern, so you could just graph it. Okay, so try graphing it, take like 3 minutes, 4 minutes, work with your neighbor. Somebody can help you. See how far you can get with graphing this. And actually, if you guys need to take a break, go ahead. I'll actually do this problem at 3:40. Need a break? I'll do it at 3:40. Okay, guys, so here, let's draw the first piece. Okay, now if I plug in 0, I get in the first function, I get 0. So open or close circle? Open. Right, because it's a less than, so 0 is not really a part of the first function. Now I could plug in numbers less than 0, like if I plug in -1, I get -2. If I plug in -2, I get -4. But notice it's a line, so do we kind of get the pattern if we keep going? Yeah, it'll just be a line with slope 2. Okay, so we could just fill that in. And we could just put an arrow saying it keeps going like this. It's a line. Looks a little curvy. Well, that's the trouble with drawing, but it's meant to be a line. Question on it? Yeah. Yeah, so everything here have closed circles. And then this one is open circle just because 0 is not part of this function. But these numbers are all less than 0. Since they're all less than 0, they are part of it, so they are closed. Yeah, so the only times you might have an open is when you don't have the, when you have a number but without the equal sign underneath, then it's not really part of it. Okay, how about this function? Now we do 0. What's 0 squared? 0, closed circle or open? Closed, but I already put an open, so what do we do?
Fill it in.
We fill it in, right? That's how we glue. We glue them. Okay, how about 1? 1 comma 1, 2 comma 4. Okay, 3 comma 9. Oh man, okay, I can't make it to scale then. I'll just put a 9 there. Why not? Not really to scale. And then 4 comma 16. Okay, maybe I could try to make it a little bit to scale. Maybe over here, closed or open circle. Right, the 4 is open circle like this. So when I try to connect these dots, it's x squared, which is a quadratic. So it'll look kind of like this. And I cheated a little bit, so let's make that point right here. Okay, so so this is all x squared. So here they connect, they glue together nicely. All the way up until 4 comma 16. So all the way up here is 16. Questions on that? Right, so you'll have a lot of questions with piecewise. Okay, x greater than or equal to 4. If I plug in 4, I get -4. Closed or open? Closed, because it's an equal sign. If I plug in 5, I get -5. So it looks like it'll be a line. And then I just go down like this to infinity. Any questions on this? Yeah, is there a question? You guys see how we did it? Did all 3 pieces. The idea is they're not overlapping because it is a function.
Be negative infinity to 16.
Good. Yes, the range will be good. Negative infinity to 16. That's true. The lowest y value is negative infinity because there just goes down to negative infinity. The highest y value 16, but it's an open circle, so open parentheses. Good. And what about the domain?
All numbers.
All numbers, right? Right. Every single x value is getting plugged in somewhere. Negative infinity to infinity. WebAssign will let you even write the word infinity. I think you start typing infinity, it'll fill it in with infinity with the symbol. Okay, is this okay, guys? So piecewise functions, see how we graph them? Yeah. Okay, in the back. Okay, the other side of the room. A question? Let's see. Like which one? Like the first, the second, or the third? Like the second one? Yeah, so it won't always be because it's just the equal sign that's making it. Yeah, so it's the equal sign that's making it a closed circle here. And then there's no equal sign there, which made it an open circle there. Oh, you mean in between? Yes, that's right. In between, they're all part of the graph, all part of the function. Yeah, you're right. So, what was your name? Yeah. Yes, Sanjita. Like what you're saying, yes, all the numbers between 0 and 4 lie here. So that means all the numbers between 0 and 4 are part of the second function. So they're all closed circles. That's right. Good. Same thing here. All the numbers less than 0 are part of this function, so they're all closed. All the numbers greater than or equal to 4 are part of this function. So those are also all closed. In fact, I didn't even need to make closed circles here. I could have just said like, oh, the function starts at 0, 0, and then it ends off at 4, 16. And I know x squared is a quadratic. And I could have just drawn a parabola because that's what a quadratic looks like. So just these dots that we're doing is just to simplify it, if you don't remember how to graph a line or a quadratic, but if you remember how to draw a quadratic function, a parabola, or a line, you could just do it even without putting in those points in between. Okay. Okay, good. Other questions? Yeah. Okay, we'll review. Okay, a couple other functions we'll be dealing with, so just so you know the name. So polynomial, it's called a polynomial. There are functions that look like this: x cubed over 3 minus 6 x squared plus 7/3, where it's x raised to an exponent with a coefficient in front. So the coefficient here is really like 1/3. Dividing by 3 is the same thing. The coefficient in front of x squared is -6. You could think of it as 0x. There's no coefficient in front of the x. So 0 is perfectly fine. So these kinds of functions are called polynomials. So cubics, quadratics, lines, even constant functions, that's the name when they have this form. So the general form is f of x is cn x to the n plus cn minus 1 x to the n minus 1 plus ... all the way up to c1x plus c0. Right, so all functions that look like this, where you have x with an exponent and a coefficient in front, which is just a number, those are all called polynomials. Okay. So what's not a polynomial? Well, what about 2 over x cubed? It's not a polynomial because these need to be positive exponents. So 2 over x cubed is 2x to the minus 3. It's not a polynomial. Right, Cn is an integer greater than or equal to 0. The polynomial is when you don't have negative exponents. Yeah, and why do we study them so much? It turns out pretty much any function, no matter how crazy it is, sine, cosine, e to the x, ln of x, you could approximate it with a polynomial, right? There's a way to take a function and get a polynomial, which is much simpler to approximate it. So you could do that with computers, and there's a formula. Okay, rational function. Sometimes we'll use the terminology of rational function. Is when you take one polynomial divided by another polynomial. So it's a quotient of 2, I guess we'll call them polys, 2 polynomials, quotient of 2 polynomials. So as a little example, f of x is equal to x squared minus 6x over x plus 5. G of x equal to, let's say, 2 over x. So yeah, these are all rational functions because x squared minus 6x, is that a polynomial? The numerator a polynomial? Yeah. X plus 5, is that a polynomial? Denominator?
Yeah.
Yeah, so numerator and denominator are both polynomials. That's what it means to be a rational function. G of x. Well, let's look at the numerator. 2. Is 2 a polynomial? It technically is. See, yeah, in this formula, notice this formula had a C0 here. So I could just make all the coefficients 0, except for C0. I don't actually have to have x's to be a polynomial. So a constant function 2 is a polynomial. Okay. And then x, just regular x, is that a polynomial? Yeah. So yeah, these are all rational. F of x equals x over sine of x. Well, is x a polynomial? Yeah. Is sine of x a polynomial?
Yeah.
Does it look like this? No. Yeah. It doesn't look like that, so it's not a polynomial. So it's not rational. Yeah, so it's not a polynomial. Polynomials are the simplest ones. Actually proving that sine of x is not a polynomial, maybe that's not so easy to do, because it doesn't look like it is, but I don't know, maybe I could figure out different CNs that might equal sine of x as a polynomial. But you could prove that it's not possible. Not possible. Not possible for any polynomial to be the same as sine of x. No question.
Could I ask why 2 over x is a polynomial with 2 over x cubed?
2 over x, let's see. So no. You're right. Maybe I just misstated it. So 2 over x cubed, it's not a polynomial, but it's a rational function. It is rational. And then 2 over x, it's not a polynomial, but it is rational. It is a rational. So yeah, so not a polynomial, but is rational. Okay, because rational functions are allowed to have a denominator that's a polynomial. So it is a rational function. So both of them are rational functions. Yeah, so 2 over x cubed and 2 over x, both of them, they're not polynomials, right? Because polynomial means just the numerator is a polynomial. But they are rational because the denominator is allowed to be a polynomial. Yes, they are both in the same category. Okay, just the terminology so that when you see them. Um, see, what should we review? Should we review sine and cosine? You guys remember the trig functions, sine and cosine? Okay. Let's see, sine of x, f of x equals to sine of x. Okay, these are the waves, the wave functions. Most common one. Sine of x, so in terms of graphing them, sine of 0 is equal to 0. And then there's pi halves, sine of pi halves is equal to 1. Then there's pi, sine of pi is 0. And then there's 3 pi halves, -1, and then 2 pi. That's the basic sine function. Starts at 0, like this. Has a wave like this. And then what happens? Well, it just repeats. It just repeats this pattern, and it actually goes on forever and ever. You can plug any x into the sine function. Same thing here. Something called periodic. But the domain, what's the domain of sine of x? Which x values could we plug in?
Negative.
All real numbers. Yeah, so negative infinity to infinity. Right, no problem with plugging in any real numbers. Okay. There's also cosine of x. Okay, so cosine of x. At 0, we start at 1, so that very important value to remember. Cosine of 0 starts at 1, and then at pi halves it goes to 0, and then at pi it goes to -1, and then 3 pi over 2, and then 2 pi. Like that. So that's a typical cosine wave from 0 to 2 pi. And then it just repeats, right? It just keeps repeating that same pattern. So the domain is all real numbers. Okay. And the way you write down the fact that it's every multiple of 2 pi it repeats is sine of x plus 2 pi n, meaning adding any multiple of 2 pi is the same thing as sine of x. Okay. So any multiple of 2 pi, it just repeats itself. This is the mathematical way to express that repetition. Okay, who remembers the unit circle? Unit circle. Yeah, okay, well, you don't have to simplify in this class, but it will save you a lot of writing. To know just some basic points on the unit circle. Okay. So the way it works is that you draw a circle with a radius of 1. Circles look awful. So oblong and oval, but it's really a circle. It's a circle. So every point on the circle, we could think of any point on the circle as having a certain angle theta with the x-axis. Okay, a certain angle theta with the x-axis, and each point here is cosine of theta, sine of theta. Okay, so every point on the unit circle. So what they do is you'll see unit circle charts. So let's do radians. Okay, so let's say I plug in 0. Plug in 0, you'll always see on the unit circle is 1, 0. Right, how does that help you? Well, it tells you that cosine of 0 is 1. And it tells you that sine of 0 is 0. So this unit circle is computing cosine and sine for you at all these different angles, the most common ones. So you'll only see the more common ones. So you might have a theta value that, let's say, is pi 6. Pi 6. So you'll have the number here, which tells you the angle. And then you'll have the point here, which let's say is rad 3 over 2, comma 1/2. So what does that tell you? That it's computing cosine and sine for you. So cosine of pi 6 is what? Rad 3 over 2. And sine of pi 6 is 1/2. Okay, so print out a little unit circle for the class if you don't remember it, and just keep using it as you do your homework. Go ahead.
So for the test, if we have a question like that, will the number be given to us or do we have to memorize it?
It's pre-calc, so what I'm gonna have to do is like, since you don't have the calculator, like, let's say you get cosine of pi 6, and like, oh, I don't know cosine of pi 6, you just leave it as cosine of pi 6, and you get full credit, right? You could actually get away with not knowing any of this, but it will help you to know the basics, just so you don't have to keep, writing down things like that. Yeah, so you don't have to compute it, but yeah, you could have a basic knowledge of it. So pi 6 is, you could also write it in terms of degrees. Some of these unit circles write degrees, 30 degrees. Here's a common one, pi 4ths, which is 45 degrees. So pi 4ths will be rad 2 over 2, comma rad 2 over 2, which means cosine of pi 4ths is rad 2 over 2. It means sine of pi 4ths is rad 2 over 2. The other common one you'll actually see is going to be pi 3rds. And then pi 3rds is 1/2. And then rad 3 over 2. So what's the mnemonic? How do you remember pi 3rds versus pi 6? So like one of the ways you could remember it is like pi 3rds, the 3, and then 1 plus 2 is 3. 1 plus 2 is 3, so 1/2 comes first. The cosine is the 1/2. And then pi 6, the 6 is 3 times 2, so the cosine is rad 3 over 2. Whatever. That's what they teach. Sometimes, some places. Okay, little way to remember it. But at least know cosine and sine of 0, and at least know cosine and sine of pi halves, because that one I'll use a lot during pi halves at 0, 1. So this angle pi halves, so cosine of pi halves is 0, sine of pi halves is 1. And then angle pi is 180 degrees. 180 degrees is angle pi. So that's -1, 0, which means cosine of pi is -1, sine of pi is 0. And then over here, this is 3 pi over 2, 270 degrees, so a little. So you go 180 degrees and then 45 degrees more. I mean, 90 more degrees, 90 degrees more. So 0, -1. So you can go ahead and print out that unit circle that has the common ones. And then it just has all the common ones with like 2 pi over 3, 5 pi over 6, 3 pi over 4. So multiples of pi 4ths, multiples of pi 3rds, and different multiples of pi 6 going around the circle. Okay, questions on this? Okay, print it out, just Google it, print it out. That's what it'll tell you. Okay, let's see, in terms of a triangle, another way you could think of sine, cosine, and tangent is in terms of a triangle, just to remind you, it's a right triangle. So there's an angle theta. So you have the hypotenuse, you have the opposite side, and you have the adjacent side. Okay. So sine theta, cosine theta tells you something about the triangle. So sine theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is sine of theta over cosine of theta. Right, so that's what tangent is, sine over cosine. So that's opposite over adj, op over adj, opposite over adjacent. Okay. So sine, cosine, tangent of different angles would tell you information about the lengths of the sides of a triangle. Questions on this? Good. The unit circle help anybody? Bring back memories? Okay, who remembers their unit circle? Or I won't quiz you, but who kind of remembers it? At least angle 0, pi halves, pi. Okay, so it'll help a little bit. You won't need it so much, but it will save you time, and we will have problems that involve sine and cosine. So just for some of the basic values, it'll help you. Okay, a quick thing about graphing that you guys should know is because students waste too much time graphing things that are pretty easy to graph if you just know a couple tricks. So like, let's say you know one of the graphs. G of x is equal to like rad x, let's say. So I could graph it plugging in points, like 0 is 0, 1 is 1. But then if I plug in something like 4, then I get 2. Now, I get this as the graph. What's a domain? Right, 0 to infinity.
Yeah.
Start at 0, plug in everything else afterwards. Okay. But now, don't get worked up. What if you see something like g of x plus 7 that you need to graph? Okay. So once you have the basic, which is rad x, graphing something like x plus 7, all you have to do is do a shift, right? So x is being replaced by x plus 7. So the plus means you shift 7 units to the left. So you just take what you know.
-7.
Right, -7, which is 7 units to the left. That's right. So -7, I'm going to move it, and I'm going to pretend like that's my origin. And then I just graph what I had before. I'm just starting it 7 units to the left. Okay, so you guys don't have to get all worked up plugging in like, how do I graph this? It looks complicated. If you know the basic function, you could start shifting things. Question?
So it was negative, you move it to the right.
That's right. If it was g of x -7, right, the -7, you'd actually move it to the right.
Other way around.
The other way around, yeah. One way to see, everything is kind of centered at 0, so you kind of think of which x value gets me back to the center. So like here, x equals 7 gets me back to the center. X equals -7 gets me back to the center. So then this one, when you graph it, right, it'll just save you guys a lot of time when you do this like that. Okay. And if you see something like more on the outside of the function, like let's say +3, and you're wondering, oh, how do I deal with the +3? Well, that's a shift in the y. You should think of something on the outside like that as not shifting your x, it's just shifting your y. So here you just go up 3. So shift x's by 7 and shift your y's up 3. So this one, let's draw it in green. So up 3. So I shift my y's up 3. So I shift to the right 7, up 3, like that. Okay, so this will just save you a lot of time in graphing. That if you know the basic function, how rad x looks like, you could graph anything like this by doing shifts. So I'll be doing that a lot. So if you're wondering like, oh, how do you graph that so fast? Well, I'm just shifting it in my head. That's all I'm doing. Go ahead.
What if it was like x/2?
Which one?
Radical x/2.
Radical x/2, good. That's called scaling, yeah. Radical like x/2 like this. One thing you could do is, first of all, is write it as radical x/radical 2. Okay, and this one would be a little bit trickier, but this is just scaling it. So it's just taking the original graph and either enlarging it or shrinking it. So since I'm dividing by radical 2, I'm kind of shrinking the y values. So I'm dividing it by a number bigger than 1. So it would still be radical x, and it might still even look like this until I start filling numbers in, but it'll still look the same. It'll just get either shrunk or expanded. Maybe a good example would be g of x is equal to 1,000 radical x. So I'm not shifting it, but think of it like if I'm plugging in 1, then I get to 1,000, then it's like this sort of this big, crazy enlargement of what I had. Okay. And that's called scaling. That's less common. Don't worry so much about that. Okay. Okay, questions about graphing, use that trick. Save you guys a little time. Okay, and here's what we really need to know: composition. Composition. This is like in 1.3. Composition of functions. Okay. F of x equals x plus 5. G of x equals x squared minus 7. Once I have two functions, or I could even do it with one function, but there's something called a function composition, where f of g of x, it's a new function, but what I'm doing here is I'm plugging g into f. I'm plugging one function in for x of another function. Okay. So how does that look like? And this is for x in domain of g. Remember, you're first plugging it into g, right? You plug in an x into g, that g spits out a number, it spits out an output. That output you're plugging back in inside f. That becomes your input for f. So as a little example, f of g of 3. So what is composition really doing? Well, first I'm doing g of 3. So what's g of 3 if I plug in 3 for g? So, Selena? 2, right? You're going to say 2 also? Yeah, 2. So g of 3, notice is 3 squared minus 7 is 2. So 3 squared minus 7, which is 2. And now what I get for g, I plug it into back in for f. So then what's f of 2? Right, 7, 2 plus 5. Okay. So I'm plugging in one function into another. Okay. Now f of g of x, I could even write it the whole thing as a function, where see g of x is x squared minus 7. Right. So wherever I see an x for f, that x is getting replaced by g. Right. That's what f of g is. F of g is the input. You could think of the whole input as being g of x. So x is getting replaced by g. So it's x squared minus 7 plus 5.
Square minus 2. Plus 3.
Oh, you mean you want to simplify it? Who wants to simplify it? Who likes simplifying it? Yeah, you could if you like, no problem. If you like simplifying it, you can simplify it. Okay. But either way, you guys see how we're getting it? We're plugging g inside f. That's the input for the x. So that this x is getting replaced by function g of x. Okay, so try a couple examples. Try the other way. try g of f of x. And try f of f. F of f. Try g of g. Plug g into g. And I don't know, for fun, how about f of g of f? Okay, but start with this one. Start with g of f of x. Plug f of x into g of x.
The very last one, you start from the right side, right?
That's right, good. If you get to the last one, yes, you read it from right to left. First, plug f into g, which you actually did in the first part. Whatever you get there, plug that back into f. Yeah, just read it from right to left. Good. Okay. Did someone get g of f? Anyone get g of f? Yeah, want to try that one? X plus 5 squared minus 7. Good. Right. So you're plugging in f, which is x plus 5, into g. Okay. See, what was your name? Monica? Okay, that's g of f. Okay, now f of f. Yes, go ahead. This is yeah, we have Nur Sultan.
Which one?
Did you get f of f?
It's x plus 80.
X plus what?
80.
So let's so f of f is it's x plus 5 here. Did you see that?
It's 5.
5. It's a 5, yeah.
X plus 10 then.
Oh, you were thinking of 9? Did it look like a 9? Okay. Yeah, if it was a 9, then you're right. So f is x plus 5. So I'm plugging in x plus 5 into f. So it's exactly x plus 5 plus 5, x plus 10. Good. Let's see. You want to try the next one? Yeah. What's your name? Yes, Neha. Go ahead. Good. Yeah. Right. Like Sneha is saying. Right, is you take G, whatever that is, and which is x squared minus 7. And then you plug that in for x. You plug that inside g. So g was x squared minus 7. So this x squared minus 7 went in for x. That became the whole input. Want to try f of g of f? Yeah, go ahead.
Would be g of x plus 5,
Good.
which would be x plus 5 squared minus 7.
Right, so x plus 5 squared minus 7, that's g of f. And now I have to plug all of that into f.
You would get x plus 5 squared minus 7 plus 5.
Minus 7 plus 5, good. Good, you go from right to left. Right, so you have f, that gets plugged into g. X plus 5 squared minus 7, all of that gets subbed right into x.
That's all.
Is there a question?
Uh,
Oh, okay. Okay, good. Okay, so you guys, it sounds like you guys were able to get these, yeah? Right, you guys see the idea for these? Okay. Let's try another example. F of x is equal to radical x plus 3. G of x is equal to x squared minus 12. So try f of g of x and g of f of x. And then f of f. See if you could do those. Hey, maybe as a class, we could all do it. What's f of g? What do we write? Anyone want to shout it out? Oh, go ahead.
I got, so I put x squared minus 12 under the radical.
Mhm.
And then I added 3.
Is the 3 under the radical or outside the radical?
But I think I did it in the reverse, but, oh wait, no, I put it on the inside.
Yes, we just have to be careful. We're plugging in g. So that means we take g and then put it into this x.
Oh yeah, that's how I did it.
But and then the 3 is still in this radical. So plus 3 still in the radical. Good. So x squared minus 9. Right, all in the radical. G of f, we plug f right into g. Yeah, you want to try?
It's gonna be radical x plus 3 squared minus 12.
Minus 12. So x plus 3 minus 12. F of f. So remember, f of f is f of radical x plus 3. So we have to take whatever complicated thing this is, replace it into x of radical. So radical x plus 3 plus 3. Okay. Okay. Any questions on this? Okay, so you'll just have a set of questions having you do this, compute g of f and f of g. Okay. And here's the other variation. Okay. So write each function h of x as f of g of x, i.e. Figure out f of x and g of x. Okay, what does it mean? It means go backwards, right? It means that in the previous examples, you had f and g, they wanted you to compute f of g. Now they're going to give you the final answer, what f of g is. You have to go backwards, figure out what is the f, what is the original g. So the example, let's say the first one, h of x is equal to 2x minus 9 raised to the 11th. You have to figure out what's the inside function, which is little g. What's the outside function, which is little f. Here's the trick that, works a lot of the time. Like what's in parentheses, right? What you see usually in the parentheses, that's like the inside function. That's the little g. Is usually g of x. The thing you see in the parentheses, that's the inside function g of x, right? Then replace parentheses by letter x gives f of x. So to get the outside function, you take the inside, replace it by letter x, and you're done. So here, you have to compute g of x and f of x. So always start with the inside. The inside is where you want to start. What do you see that's like in parentheses? What's your name?
Jonathan.
Jonathan?
That's fine.
2x minus 9. Good. Let's see, and Jonathan. Yeah, and Jonathan, if you replace 2x minus 9 by x, you get f of x. So what is f of x going to be? X to the 11th. That's all you guys have to do. And test it. You could just test it. Compute f of g, plug g into f, and you'll get back to what you started with. Right? And then that works. So that's what the WebAssign is going to be asking you to do. Right? Figure out, go backwards. Figure out little g, figure out little f. Let's do another example. H of x is equal to cosine of x cubed minus 8. Okay, figure out what's inside, figure out what's outside. Want to try?
Yeah, so
G of x?
g of x would be x to the third minus 8.
X to the third minus 8. And f of x?
X.
Cosine of x. Right, and we could always test it, compute f of g. Just compute f of g and then you get it. Right, so you guys see how you do this little trick? To get the inside, it's like what you see on the inside is usually the parentheses. Now, if it doesn't put parentheses in the problem, you kind of have to imagine your own parentheses. Here's what I mean, like h of x is equal to e to the x squared plus 11. You have to kind of just imagine for yourself, if I had to put parentheses on an inside function, like where would I put my parentheses? Where should they go? What looks like the inside? Go ahead. Right, x squared plus 11 looks like the inside. So g of x is
Square is plus 11.
plus 11, and f of x is,
X.
right? The parentheses gets replaced by x, so we get e to the x, right? The exponential function. Okay, and e to the x, you guys don't remember, e to the x, when you graph e to the x, it's an important one, 0, 1. And then here it kind of decreases like this. And it goes up like this, really fast. Super speed upwards. Okay. Any questions? Does this make sense, guys? Do you see how we do composition? That's really the piece that you need on your homework for this. Okay. Anyone still unsure about this? Okay. So I'll send out an email, but on Wednesday, what we're going to do is we'll take our first quiz. So usually we'll take a quiz every week, like on the last 2 sections. So it'll just cover what we did today, which is lines, composition, and what we did last time, which is domains. And it'll be short, like 10 or 15 minutes, couple of questions. It'll never be more than 3 questions. So max 3 questions. We'll do it at the beginning of the class. That's why BSDO students, see if you can get out like a couple minutes so you have full time on the quiz. But I'll send an email announcement just so you guys can expect that. And so it'll be in class. Okay. And then the